and I can help you with them after class or during the break. Okay, now,
I'm sorry, are you going to add more questions, like test questions?
what I really want you to do for the final is really focus on knowing the project.
Okay.
Okay, we don't have a whole lot of time here. And I'm going to talk about a lot of the analysis that pertains to the project in a few minutes. I want you to know all that stuff. So there's actually quite a bit of stuff to cover with the projects and small practices.
Okay.
Because again, it's not a big body of material, but it's pretty detailed stuff.
Okay.
Okay, so now we have the 1 month T-bill. We have the 1 month return on Newmont. And we have the 1 month return on the market index. So to calculate the CAPM, I need the excess return on Newmont, and I need the excess return on the market. Okay? So the first thing I'm going to do is calculate the excess return. Let me move this stuff over here. Okay, excess return on Newmont. This is going to be equal to? This is simply equal to this minus the T-bill return. So it's simply equal to the Newmont monthly return minus the 1 month T-bill return. Okay? Now you might say, you're subtracting what's essentially 0 from something. Why do you even bother to do that? The answer is, given the numbers, given this time period, it would make virtually no difference. But these are not normal times. If times were normal, it would be important to do this. Okay? So I simply don't want to do the example incorrectly, given our very unusual data. So let's do it the right way. Okay? And I'm also going to have to calculate this for the entire series, so I'll just copy this and paste it down. Come on. Okay. Now I need the excess return on the market. Return on VTI, which I'm using as my proxy for the return on the market, minus the return on the 1 month T-bill. Copy that, paste that in. Okay. So now I have the excess return on Newmont and the excess return on the market. Yes.
Can you just go over really quick how you did the expected return on the first, the one that you just did at the NEN?
Okay, this one here?
Yeah.
Okay, so the expected return on Newmont is the return on Newmont
Minus the one on
minus the T-bill return. Okay? Okay, so I've got all the inputs I need now to calculate the beta of Newmont mining, which we use to calculate the expected return. So what do I do next? Well, I'm going to use the regression tool in Excel to calculate the beta. Notice here that the beta is equal to the covariance of Newmont and the market divided by the variance of the market. That is actually exactly the formula for the slope coefficient from doing a regression of Newmont on the market's excess return. Remember, you had stats, and you learned how to do a simple linear regression. The beta is calculated simply by doing a simple linear regression of the excess return of Newmont on the excess return on the market. Okay? So how do I go ahead and do that? Well, let's go into data. I need data analysis, and you can see it's no longer here, even though I downloaded it on Thursday. So we'll have to go and download it again. Let's see, options, add-ins. Okay, I need the analysis tool pack. Now it shows up here. Question? Okay, so Excel has included a number of extremely useful analysis tools that let you do statistical analysis, correlation, covariance, do Fourier analysis if you are an engineer, make histograms, calculate moving averages, do random number generation, etc. We're going to do statistical tests. What we're going to be interested in, however, is the regression tool. So I click on the regression tool, and the first thing it asks me for is the input, the Y range. What is the Y range? It's the dependent variable in the regression. What would the dependent variable be in this example? It would be the excess return on Newmont. Okay? So I'll put in the range. You know, before I do that, let's go here and make sure I've got the same number of months, because that would screw things up real fast. I'm just going to delete the bottom here. Okay, so now I've got exactly, I've actually got a little bit more than, I've got 5 years and 1 month. Okay, that's fine. When you do it exactly as I ask. Okay? Actually, I'm setting a bad example here, so let me get rid of this. Let's go back to data analysis, regression, Y range. I'm simply going to highlight the range where I have the excess return on Newmont. You know, I'm going to make one more change too. Sorry about that. So you have labels. I'm actually going to move this down here. I'm going to move this down here. Because then I can highlight the entire range. I'll actually have a name of each one of my variables. Okay, so let's go back into data analysis. And I'll save the spreadsheet and post it online in case you're interested in seeing that. So now what I'm going to do is I'm going to change this range to include the label excess return on Newmont. Okay, and I'm going to click here labels. And what that tells Excel is that the first cell in the column is the name of that column, which in this case is the excess return on Newmont. Okay, what do I put for the X range? Excess
Market.
return on the market. Okay. Now I'm gonna have to put the output somewhere. Just put it over here. Oh, see when I screwed that up? I gotta put the Y range in again. Okay. Output range. That over here. Now, I'm going to ask for the line fit plot. And I'll also ask for the residuals. And then this will become part of the output that Excel will give me. Okay? Let's click OK. And see what we have. Okay, let's look at this picture. The red dots here represent the predicted expected return on Newmont based on what the market did. So what the regression line is doing is it's calculating the line of best fit. Okay? It's calculating the regression line, which minimizes the sum of the squared differences between the line and each actual data point. So it's the best prediction, the best statistical prediction that we can come up with. If I tell you that the market did this, then statistically, the best prediction we could make for Newmont would be this. If I tell you that the market did this, our best prediction would be that Newmont did this. And you can see this line is quite flat, okay? It's typically not this flat. Now I can go in here to Excel and, let's see, add trend line, and linear trend line. Okay. I can format these data points. Make them a little smaller. Okay, so that's actually the regression. Now, what is beta? Beta is actually the slope of that line. I can actually have Excel give me the formula for that line. Let's see, trend line options. Display equation on chart. So if you look at this equation here, this says that the predicted Y is equal to, this is the intercept, minus 0.0015 plus 0.3598x. The beta of Newmont then is 0.3598. Okay? Now, one thing you might be interested in knowing is this statistically significant? It doesn't look like the line describes the returns very well, does it? Okay, it looks pretty random. So you might ask, is there a statistically significant relationship between the excess return on Newmont and the excess return on the market. How would we answer that question? Not here. You have something special going on this week? Yankees finally won. Is that a 5-game losing streak? I can only make so much chit chat. Come on, what's the answer? What do you want to know about? Is this a statistically significant relationship? Yes? How do you know? How about we look at the t-stat, or the p-value, or the r-squared? Let's go over and see. Excel actually gives us statistical analysis as part of the output that lets us assess the significance of the relationship between Newmont and the market. Okay? Now, let me change these column sizes a little bit so you can read this a little bit more easily. These two columns here, because we don't need them. Okay. So let's look at this output. What is the r-squared of this regression? It's the explained variance, or the explained variation, divided by the total variation. Now, I've got all this stuff I'm going to tell you in the set of slides, but I wanted to go through this output in Excel, because if you do this sort of analysis in your internship or on the job, I mean, you're going to be working with Excel. So let's see where these things show up in Excel and how you would interpret them. Okay? So the r-squared is the explained variance, or the explained variation, divided by the total variance. The multiple of r is actually the correlation. It's the correlation between Newmont mining and the market. So the correlation is 18%, the r-squared is 3.2%, and you can verify for yourself that if you square 18%, you'll actually get 3.2%. That's why this is called the r-squared. R stands for correlation, okay? So the correlation squared is the r-squared. The adjusted r-squared is a statistical term that takes account of the fact that even if both data series were totally random, by chance you'd expect there to be some, you'd expect there to be a positive r-squared, just by chance. Okay? Now, let's go down here. I'm not going to talk about doing it in ANOVA. You probably talked about how you do it in ANOVA when you took stats. Down here, we have the coefficients for the regression. The intercept is minus 0.001. The slope coefficient, which is the beta. This is the beta here. Okay? Is 0.3598, so it's about 0.36. The standard error gives us our measure of confidence in our estimate of this coefficient. And the way we come up with our measure of statistical significance is by dividing the coefficient by the standard of error and getting the t-statistic. Okay? And you can see in this case, the t-statistic for the intercept is essentially 0. The t-statistic for the beta is 1.38. Now, the rule of thumb that you probably recall when you took stats is that to be confident that the true value of the coefficient is not 0, to reject the null hypothesis that the true value is 0, we need a t-stat of at least what? At least what? 2. Good. Need a t-stat of at least 2. Okay? That gives us confidence that the true value is not 0. The p-value gives the probability of making a mistake if we assume that the true value is not 0. To get a t-stat of about 2, we would get a p-value of about 5%. Okay? So what would we conclude by looking at this example? Is the excess return of Newmont statistically significantly related to the excess return in the market? No, it's not. Okay? Now, I doubt that that will be the case in the stocks that you do the analysis for. Okay? But it's certainly possible that you'll get a t-stat that's not significant. What would cause that? Why do we actually get that? Again, let's go over and look at the picture. Why does it seem to be quite random? Newmont's a gold mining company. The price of gold can fluctuate for reasons unrelated to the fluctuation of the market. Evidently, the macroeconomic factors that determine the performance of your typical stock are not the same things that determine the price of gold. Okay? What would determine the price of gold? Some people say that gold, buying gold is called the Armageddon trade. Okay? It's the trade that you make when you're concerned about everything falling apart. Okay? This is one of the reasons why some people think that buying gold can be a hedge, because it doesn't necessarily go down when the market goes down. Okay? Now, how does what actual investment managers do compare to this type of analysis? This is just the briefest of introductions into the type of statistical analysis that a professional money manager does. Professional money managers will oftentimes do regressions where they have 4 or 5 different explanatory variables. So they have to do multiple regressions, and they'll look at the sensitivities of stock returns to different macroeconomic factors, or different proxies to macroeconomic factors. We'll talk about this next time. Okay? But one thing I want you to understand is that professional money managers, investments professionals, have to know statistics. Okay? It's a big part of what you do. Because ultimately, describing the relationships between asset classes is a statistical exercise. Okay. Any question about this? What? Sure. The t-statistic is actually calculated, and you can verify that. This t-statistic right here